Hello guys, we are going to talk about two main formulas that we will use with finding the area of a sector and also finding the arc length of a sector. Okay, so we're dealing with radians. We've been learning about converting radians to degrees and vice versa. And we've been learning about the unit circle. Now we have another way of using radians and two formulas. Okay, so first of all, let's talk about what a sector is. Okay. A sector is a piece of pie out of a circle, basically. Okay, so in a sector, it's a region enclosed by two radii and an arc. So this is a radius from here to here. That's a radius, r. And this is also a radius, r, because it goes to the center of the circle. This is an arc. Okay, we actually call that an arc length, and we give it the symbol a lowercase cursive L. Okay, so it's an L is arc length. And that means that arc on the outside of a circle where a sector is. And a sector means a section of the piece of the circle. Looks like a piece of pie or a piece of pizza. Okay, we have two formula we can use for this. Arc length is equal to radius times theta. Now theta represents an angle. For these two formulas to work though, very, very, very special, theta must be in radians. So your angle has to be in radian measure. If it is in degree measure, then you have to change it to radians. Okay, and you can all do that. Let's recall, if your question is in degrees, so we have so many degrees, number of degrees, we multiply by pi radians over 180 degrees, and that will give us the number of radians. I'll leave us with the number of radians, okay, because remember, degree units will cancel there and there, leave us with degrees. So we have the number of degrees multiplied by pi over 180. That will give us how many radians we have. In case you have a question where you have only degrees given to you and you need to change it to radians. All right, so two formula, arc length. So L is arc length, R is radius, so the length of the radius, and this is the angle in radian measure. Okay. Similarly, we can figure out the area of a sector using this formula, 1/2 theta r squared. And again, theta here is the angle, and it must be in radians. And here, this is still radius as well. Okay, so two formula that you need to know for this little section. All right, let's look at the two examples in our textbook. Example 2 has this circle where we have a sector here where this is 3 pi over 4 radians, this angle, and our radius is 8 centimeters. We need to find the arc length and we need to find the area of the sector. All right, so arc length. Well, our formula said that arc length, I'll do it out here, arc length is equal to the radius times theta as long as theta is in radian measure. All right, so the radius up here is 8 and the angle is 3 pi over 4 radians. Sorry about that little mark on my whiteboard. It's just a permanent stain there now. Part of the white flashy stuff has ripped off. Okay, so multiply across our fractions, multiply the numerators together, 24 pi over 4. Simplify that fraction now, and that is 6 pi. All right, so your answer is 6 pi. The arc length for a situation like this, so the arc length being outside of this sector, that length is 6 pi centimeters. If you want to know what that is in a decimal approximated answer, you could do 6 multiplied by pi in your calculator, and that will give you 6 pi 18.8496, so approximately 18.8 centimeters, just to give you an idea. But the actual answer would be 6 pi. That's the correct answer because that's an exact number rather than a rounded off number. Okay. Next example, example 3 from your textbook. Find the shaded area. Find the shaded area. Okay, so here we have our diagram. We have this sector, which is AOBC, around here, this sector. And we need to find the shaded area. All right, so in order to do that, we would start off by the area of the shaded region. Let's think about this. What can we actually do? Well, we know how to find the area of a sector. Oh, I didn't finish this question up here. Sorry, let's go back there and do the area of the sector. Here we go. Back to this one. Area equals 1/2 theta r squared. Okay, that's number B of example 2. So 1/2 theta must be in radian measure. So that's the 3 pi over 4 still. And radius squared. Okay, so there we have that. We need to now, this will equal 1/2 times 3 pi over 4 times 64. Okay, going to bring this down here. Sorry about this messiness. Please keep your work organized. And now we have equals 3 times 64. 3 times 64 is 128. 192, I believe. Let's just check that. 64 times 3, 192. Yep, so 192 pi over 8. I believe we can simplify that. 192 divided by 8 is 24 even, so that's actually 24 pi. The units here would be centimeters squared. Okay, 24 centimeters squared. Again, if you want to really have an idea in your mind how big that number is, you could do 24 multiplied by pi and find out. Okay, 3.14, but use the actual pi button, not the 3.14. All right, back to example 3. So the area of the shaded region will be the area of the sector, subtract the area of the triangle. Okay, so here's the sector, that pie shape. Here's the triangle. Okay, and then that will give us the shaded area. Alrighty, so area of the sector, we can do that. Here's my blue. Area of the sector is 1/2 theta r squared. Do we have everything we need there? Do we have theta? Yes. Do we have r? Yes. Area of a triangle. Now, this is non-right angled trig. Okay, we've already studied non-right angled trig. We have a formula for area for that, and that is 1/2 AB sine C. Okay, so remember, let's recall back. Here's our triangle. We're dealing with this triangle right here, where this side is 6. This angle is 2 pi over 3. We know this side is also 6 because it's also a radius. And in order to use this formula, we have to have 2 sides and an included angle, which now we have. Okay, so we actually have all the information we need for this. All right, 1/2 theta r squared. 1/2 theta is our 2 pi over 3. R is the 6 squared. So that'll be the area of the sector. And then 1/2 AB sine C. AB are the 2 sides. So 6, 6. And sine of that angle, 2 pi over 3. Now, this is a special angle in our unit circle. you can actually do this without a calculator. So go to your unit circle, find the sine of 2 pi over 3. This is where your unit circle is going to be magic for you. Okay, we have to do this. We get, I'll do one more step here. This will be 36. This will also be 36. Okay, let's look at the unit circle. Sine 2 pi over 3 is, there's 1 pi over 3. 2 pi over 3 is at this position where we have negative 1/2 and root 3 over 2. Okay, and we're looking for the sine, which is the y coordinate. So that's going to be root 3 over 2. All right, here we have, so that's 6, that'll be 12 pi when you do that out. And this will be 4, 9, this will be 9 root 3 when you do that out and simplify it out. If you need some help with those, you can see me at tutorial. So you could leave your answer like this, and if we wanted a rounded decimal answer, then we would poke that in our calculator and see what it is. Okay, so let's do that. We have 12 pi, subtract 9 root 3. And we get 22.1, which is the same answers they have on the notebook. Okay. So in this case, roughly equivalent to 22.1. And that's an area. Our dimensions are in centimeters. There's 6 centimeters right there. So this would be centimeters squared. There we have it. Have fun and enjoy doing your homework for this section.